recording. There we go. Okay, there we go. So we started a little bit late. So again, the model for this training class is going to be the design methodology for both the exercise and the evaluation process that we use for the Cascadia Rising exercise. And again, the important takeaways here are to basically take these fundamental concepts, and you can rework them to suit your specific emergency exercise requirements. In Cascadia Rising, FEMA was particularly interested in high-frequency assets. In the words of the Deputy Director for Disaster Communications, high-frequency radio was the weapon of choice. And they were interested in our networks. At the time, we were operating under the auspices of NTS, and they were intrigued by NTS because of it. Obviously, it includes many of the factors that are beneficial within the amateur radio service, one of which is the naturally dispersed individuals within the disaster area, the fact that amateur radio service is decentralized, obviously not reliant on distributed infrastructure, and high-frequency radio, of course, being immune to topographical problems and the like. So, the lack of reliance on, say, distributed infrastructure in the form of the public switch telephone network, the internet, et cetera, was the main reason for the interest. We sought to design an exercise that, of course, was mode neutral. So we wanted the emphasis to be on maximum interoperability. We wanted to make sure that the exercise would provide deliverable metrics to served agencies, and that's either FEMA or its defense contractor that was working with them on the exercise. So again, we had to provide this communications between that simulated disaster area in the Northwest to the National Response Coordination Center in Washington, D.C. So we're going to talk a little bit on how we went about it and, kind of what we were looking at in this exercise. So, our philosophy at RRI kind of began to emerge during this exercise. Obviously, we want to have standardized procedures. We want to have a universal message format that provides superior accountability and network management tools for things like message prioritization, accountability, message servicing, message tracking, things of this nature. We want to have some unified national level management processes to facilitate coordination across jurisdictional boundaries. We wanted to have full interoperability, and we wanted to include both common denominator modes, these universal modes like voice and CW, in addition to the digital traffic network, which is a modified hybrid mesh network. And so our exercise was designed essentially to look at all of these different capabilities and methodologies that would be inherent in a disaster telecommunications plan for a high-frequency radio network. So this basically meant testing the reliability of, say, the amateur radio service, NTS in particular, to maintain connectivity across a broad range of RF propagation conditions. We wanted to examine the relative performance of individual networks within the system by measuring timeliness, message accuracy, general operator performance, et cetera. And so this brings us to, I may mention this in a later slide, but here's the one takeaway from this course that you really need to keep in mind, and that is that all disaster exercises need to be realistic, they need to be attainable, and they need to be measurable, okay? So one of the great drawbacks in most amateur radio emergency communications exercises, and I've seen this from the professional end as well as the amateur radio end, and it's blatantly obvious once you realize it, is the reality that most amateur radio components within disaster telecommunications exercises test the ability to establish connectivity, but they don't actually test the communications process. That is the entire process from when a message is tendered for origination to the time that message is delivered. In this case, we measured the time and accuracy from the point at which a message was tendered for origination in the disaster area until it appeared in the data stream at the National Response Coordination Center. So the takeaway here is that the ability to establish connectivity is only one small piece of the communications equation, right? So when we went ahead and designed the exercise, we wanted it to be realistic and measurable. And we also wanted to measure the entire communications process, okay? And success would be based upon that entire process. One of the things that we obviously had to look at was whether or not NTS had a national response plan, and it never has. Nobody ever sat down and seriously asked, how would NTS respond to a major national level emergency, such as Cascadia Rising? So before we could even engage in designing an exercise, well, the purpose of a disaster exercise of any type is to test the plan, right? So if you don't have a plan, well, then you really can't have metrics, right? And you really don't have anything to test. What you have is an ad hoc gathering of radio operators, some good, some bad, no yardstick, you might say, against which you can measure performance. So what we sought to do first and foremost was to design a plan. So everybody here, I think, understands how NTS is structured and how it operates, right? It has this traditional cycle of nets. The nation is kind of built up into a set of inverted pyramids where you have state or section nets, perhaps local nets below those. So traffic moves up an inverted pyramid from the local or section or state level to the region level and to the area level, okay? And then, of course, there's an inter-area traffic net that moves traffic between areas. And then, of course, the traffic kind of trickles down through, from the area level back to the region level to the destination section or state. Now, this system of layered nets works quite well for routine, everyday radiogram traffic. It keeps nets kind of oiled and active, keeps operators involved, and it works quite well. But obviously, particularly in the 21st century, you really can't wait necessarily for, a net schedule to move priority or emergency traffic. So it's necessary to have a methodology to essentially configure nets in such a way, or reconfigure nets in such a way that they're designed or activated through appropriate directives and procedures to manage the demand for connectivity and throughput and the timely propagation of messages through the network. And that's what a national response plan is designed to do. And of course, because this had never been done, we kind of had to look at the network infrastructure and how we could reconfigure it. So, waiting for message traffic to move, through the various net layers, particularly for the priority and emergency traffic, really wasn't practical because of the long message propagation times. Okay. Now, that's not to say that the structure can't be applied. So, for example, a section net can be activated to support a major disaster in your state. And assuming staffing is available, it can operate 24/7. If several states are involved, you can activate a region network. So, it's not to say that this is necessarily a bad arrangement. But obviously, as many of you know, this National Traffic System Network that we described in our TR-002 class is not only a system of layered nets that are are basically geographic in nature, but they're also sequenced in a sort of time domain relationship, right? So, your state or section network meets at, for example, maybe 7 p.m. Your region net meets at 7:45. Your area network meets at 8:30. This handles outgoing routine message traffic. Likewise, traffic coming into your state comes from the area network at 8:30 to a region network at 9:30 in the evening, for example, and then maybe arrives at the state network at 10 p.m. This is more than adequate for routine traffic, but problematic if you need to get a situation report or an operational readiness report to an agency on the other side of the state. The exception to this, of course, is the digital traffic network, this modified hybrid mesh network that operates, 24 hours per day. It does automatic forwarding as soon as traffic is uploaded. It propagates through the system fairly quickly. And that's a whole different animal, right? Because it's automated. You don't need the time domain sequencing for DTN to operate. You simply have the layers operating as needed, throughout the day, 24/7. So two different methodologies here, right? We have the time sequenced manual mode nets, CW and voice mostly, maybe some manual mode digital nets at the section level. Then, of course, we have the digital traffic network. It's configured in much the same way with section hubs are possible, even local hubs, region hubs, area hubs, etc. And this, of course, offers some advantages, also offers some disadvantages, right? As we discussed in the emergency communications planning class, every ham station has a microphone. Every ham station, you can plug a key into it and communicate in CW. So you want to have the common denominators in addition to the automated systems like WinLink and digital traffic network. And so, again, the tools are there, but the real trick is how you apply the tools. And that's what the National Response Plan does, is it manages the tools. Okay, it addresses issues of message prioritization. It allows an emergency management director or his designee to activate certain nets, set up special point-to-point circuits, do things that are necessary to expedite the flow of communications traffic. We can change the connect and download frequency at the RRI WinLink gateways. We can, for example, increase the connect and download frequency, recommended connect and download frequency for digital traffic stations at the section level. All of this can be accomplished at different rates or in different locations as required by the disaster situation. So again, we see value in all of these, and therefore in designing our Cascadia Rising exercise, we made sure that we had available voice methods, CW methods, and the digital traffic network. Okay, so let's kind of go by. We don't really need to talk about this too much, but I do want to dig deeply into into the National Response Plan. So again, because everybody here has been through the prior class on how the traffic system operates, for Cascadia Rising anyway, what we did is we set up a specialized, we would call it in our current emergency plan, priority entry point frequencies, okay? In which radio operators would expedite the flow of radio telegraph or radio telephone traffic from the disaster area to the National Response Coordination Center. And so the idea here was to repurpose what we call IATN. That's the circuits that would typically link the area nets. Within the prototype plan that we used for Cascadia Rising, these were transformed into what we would call priority entry point frequencies. where people in the disaster area could inject priority or emergency, perhaps I should say test priority or test emergency traffic during the exercise. So these served a special purpose that was somewhat different than what they do day to day, but the fundamental skills, the fundamental capabilities of the operators, the frequencies used were very much in conformance with day-to-day operations, only the task changed. So that was one of the changes that we made within the prototype national response plan. So we established these watch frequencies for both voice and CW at various frequencies in the HF spectrum. These became specialized point-to-point circuits where traffic could be injected in the disaster area and routed to the National Response Coordination Center. And again, these were limited to exercise priority and emergency traffic only. And then IATN was running parallel to this, these voice and CW nets during the exercise to provide that common denominator access, right? And so, you could, use them for overflow traffic. They could be a primary resource depending on the needs and the needs of the local section or local MCOM group. And they provided that redundancy. They also provided, perhaps in some organizations, the primary method, right? I mean, CW and voice operators might be scarce, but you got some people, say, with Vera capability and access to the digital traffic network, then you can use that as a route. So we activated essentially those methods for Cascadia Rising. And again, the idea here was to provide multiple injection points to manage RF propagation, to essentially load balance or spread the traffic load. We wanted the capacity to dynamically respond to network failures. And that's one of the advantage of manual modes, right? Radio operators are dealing with things firsthand. They have the ability to move to different frequencies. They have the ability to change modes. They have the ability to do some things that automated networks couldn't do. So we had the ability to essentially deal with network failures and bypass them. And because of the radiogram format, we had full interoperability between all modes and networks. We didn't have, say, a different messaging methodology in Washington State than we did in Alaska, or a different message format being used on, say, one network and a different message format being used on the other. So true interoperability is not just the ability to establish connectivity using different modes and frequencies, it's the ability to have a message flow between various modes, networks, states, regions, etc., and remain intact without confusion. Okay, so essentially, we're going to take a little look here at some of the other issues. Obviously, we need to have a plan. So we developed the prototype national response plan. And then what we did is in response to the simulated disaster, we developed a frequency and network management plan that we distributed to operational units and individual participants in the disaster area. We purposely did not publish this information on the web. The main reason we didn't want to do that is we didn't want spontaneous volunteers necessarily bypassing their local or section ARIES or NTS nets. So we kind of kept it under wraps. You might call that a degree of communication security, okay? And we were also perhaps concerned that there might be the occasional nut who might want to jam or otherwise interfere with the messaging process. So in advance of the exercise, we did considerable research into frequency usage, whether or not there were contests going on, what nets are currently scheduled on what frequencies. And then we went ahead and identified frequencies for the region, area, and IATN levels, okay? And then additionally, we assigned frequency designators to identify those frequencies. So if for some reason there was a malicious interference or something of this nature, one radio operator could say, move to frequency NRC, and they could move to frequency NRC. The guy listening in would have no idea what that frequency is, right? So we did allow for a small degree of communication security in the process. And in doing so, we created a mode frequency matrix. So this might be a good example, right? Of a mode frequency matrix. You have a network designator, for example, Whiskey Alpha Alpha, that represents, 3563 kilohertz. Mode CW at night. Whiskey Alpha Bravo might be, 7038 kilohertz. Mode CW in the day, and so on. And we issued these frequency matrices with the detailed exercise plan, okay, for the participants. So this is a mode frequency matrix for the digital traffic network for the exercise. So people would know what nodes are available, what alternate nodes are available, on what frequencies, and so forth. And these were all included with the exercise package. So again, this allows for a degree of, let's say, improvisation, right? If you can't connect to the node that maybe it's in your area for whatever technical reason, perhaps lack of circuit capacity or a technical problem, there's other nodes that you could locate in this matrix and move to use one of those modes or in frequencies as an injection point for the digital traffic network. And this is the IATN circuits. So these were those priority entry point circuits for manual modes for traffic of priority, test priority, or test emergency, moving to the National Response Coordination Center. Okay, so again, frequency designator, frequency mode, watch frequencies designated by either day or night. And of course, obviously, the IATN operators might be monitoring multiple frequencies at their stations, waiting to accept that traffic and move it across country. This might give you kind of an idea of the topology of how the system works. So messages were basically tendered for origination in the states involved, and those could be injected either into the, at the time we called NTSD, the Digital Traffic Network, or they could be injected into one of the long haul priority entry point frequencies for the long haul CW or voice circuits across country. They moved to the EPA section, which was designated as the clearinghouse for the communications traffic. And then the EPA section personnel were assigned the duty of effecting delivery to the FEMA National Response Coordination Center for the exercise. Okay, a very straightforward network topology, right? Because we were looking specifically for situational awareness type traffic for this exercise, as well as what are called operational readiness reports. And we'll touch on that here in a little bit. So once that was kind of laid out, right, we created an exercise plan with designated frequencies and so forth. We wanted to essentially set up a methodology for evaluation. Some questions that we wanted to have answered were pretty straightforward. Obviously, is connectivity established and maintained? Okay, so again, this is usually the only measure many ARES groups and sections use. They don't necessarily go beyond whether or not connectivity can be established and maintained. Is the network survivable under variable propagation conditions? So another thing we did during the Cascadia Rising exercise is we selected 3 different time periods, okay, to determine whether or not communications could be maintained under 3 different sets of propagation conditions: midday, during, say, maximum solar absorption, early morning and evening, so that the networks would have to confront a variety of propagation conditions. Okay, so not only are you asking, can I establish connectivity, but what we're asking is, can I maintain connectivity regardless of propagation conditions? Okay. And the other thing we wanted to ask, is the network capable of accurately conveying information? Okay, in other words, if I stick a message in Washington State or Oregon, uh, does it come out the same way at the other end of the pipeline in the data stream at the National Response Coordination Center? Okay, because again, what's really important is the message itself. Okay, and then we wanted to measure the message propagation time through the system. How many minutes does it take for a message to get from, say, Alaska or Washington State to the served agency in Washington, D.C.? That's a very important question to ask in a disaster. Finally, we wanted to see if proper accountability and network management data was in place. Okay, again, accountability is critical to the disaster telecommunications process and the emergency management process. So we wanted to look at that as well. So these are the 5 questions that we felt had to be answered in both designing the exercise and designing the evaluation process to answer all of these questions. Okay, I'd like you guys to think about this when you design a disaster or an emergency communications exercise for your Aries group or your state section, whatever. Is am I just measuring connectivity, or can I answer all of these questions? Okay. And so these were the keys to designing it, right? Because if you'll remember from our emergency communications planning course, the emergency communications pyramid, our first responsibility is survivability. Will my, basic communications tools work when they're needed under worst case scenario conditions? Do I have the flexibility to respond dynamically to not just the disaster operation itself, but to radio conditions, on high frequency radio, that's variable propagation conditions, et cetera. Maybe in the VHF, UHF spectrum at the local level, that might be the loss of one or more critical repeaters. How do I manage circuit capacity and message prioritization? And when necessary, how do I implement some degree of natural communication security? So in our design of the exercise, we looked at all of these factors, and they kind of play into those 5 questions that we asked in the earlier slide. Okay, so we're looking at not just our ability to format a message, but we're looking at the overall network performance. So I'm going to give you an analogy to kind of what we're looking at here. So if you sit down and try and design, say, a avionics or a train control network for a transit system, okay, there's kind of a chain involved. Okay, so for example, you have the train detection technology itself. You might have certain interlocking processors that prevent 2 trains from colliding, say a crossover or something of that nature. You have specialized relays and other devices, and you may have wayside signals that signal the train driver or locomotive engineer to stop or proceed at restricted speed, etc. And there's a concept that's more popular in Europe than it is here in the United States, what's called the safety integrity level, right? And that the SIL measurement. SIL 4 is really the highest level of safety. So if I design everything in that network to comply with the highest level of safety, except for one element in the chain, my total safety level defaults to the lowest safety integrity level. Okay, so I have 4 components in, say, my train control network. Okay, and everything is designed to SIL 4 except for maybe the control relays. my total safety level is just going to be SIL 1. So in my emergency communications exercise, I'm looking at multiple processes and I'm looking for any weak links in that chain. Okay. Let me digress into some of our other training classes. I do want to state unequivocally that our served agencies, whether that's a small volunteer organization or your local public safety agency, um, if they're going to use amateur radio services, they should have a reasonable expectation that you can deliver the services that you promise. And of course, what we want to look at is and test is whether or not that assertion is true. Okay. So in our exercise, we wanted to look at the ability to survive these variable propagation conditions. We could operate throughout basically a 24-hour period. We weren't operational 24 hours a day, but we had periods that tested the network during different propagation conditions at different times of day to fulfill that requirement. We looked at accuracy, right? We looked at message propagation times through the system, and we ensured that there was enough message traffic originated to ensure a degree of statistical certainty. Okay, and what we're looking for is we're looking for that weak link in the communications chain, right? And there's weak links everywhere. You know, going back to our train control network analogy, I can design a, very high level, very safe, redundant, vital, fail safe train control network. I can train engineers well. But if the engineer decides to get drunk and do something stupid, I still have disaster on my hands, right? So one of the mistakes I think radio amateurs make is they assume that technology will solve all communications problems. And so, for example, I can take a radio operator and put him in front of a digital terminal. Pactor is a perfect example, a WinLink, digital traffic network. The digital mode itself has quote unquote error correction, right? There's a digital checksum and so forth. And, that's all, confirmed. Unfortunately, we all know the expression garbage in, garbage out. If the radio operator doesn't exercise care in the formatting of the message as he types it into a data terminal, if he doesn't assign the correct date time group so that the message is placed in the correct temporal context, well, lo and behold, we have a human factor failure, okay? The human factor element is every bit as important as the technology. And I think as radio amateurs, we're sometimes so enamored with technology because, it's kind of what we are. We're tech guys, we like technology, we like radio communications and so forth. But when it comes to emergency communications processes, the human factor is equally important. People are properly trained, they use the correct phonetic alphabet, they have experience working under suboptimal conditions and conveying that communications traffic. And the processes, say, at the input side of the communications process, that is maybe having somebody review message traffic before it's released into the system, is sometimes every bit as important, if not more important, than the technology itself, right? So that's another thing we wanted to look at. So, we're looking for things like, human interface problems, data entry errors, misunderstandings related to technical terms, okay, loss of accountability data, authority, position, etc., that goes with radio messages. Errors in date time groups that can be, as we mentioned in the emergency communications planning course, having the wrong date time group on a message can be a really critical failure because emergency response personnel are looking at trends. Okay, they're looking at the increase or decrease in available, patient capacity in a trauma center, or they want to know what the flood gauge is at a particular location, or things of that nature. You have to ensure that all of these details are correct. None of these things here really are technical issues. They're people issues. And this is why firefighters and law enforcement officers and soldiers drill, right? They go to the range and they practice with firearms. They do controlled burns. They exercise. They have drills and so forth. Is because the human process is critical to the response. And this is why RRI encourages traffic handling, not so we well, I guess it is so we can have a little bit of fun pushing radiograms around. But the value in that radiogram to your grandma, wishing her a happy birthday, is the value is not so much in the message. You can send that via email or call her on the phone. The value is in the drill. The value is in learning the process and having it become second nature, so that none of these errors occur. So, here's an example that I thought might be kind of entertaining. In front of you are two aspirins. One is a baby aspirin, or an aspirin that some of us adults take due to, past or potential cardiac issues. Little 81 milligram aspirin. The other one here on the left is an aspirin that I administer to horses. Okay, the average human being, I don't know what the average human being weighs, maybe 150 to 100 or 200 pounds. Different for men and women, of course. What does the average horse weigh? Well, the average horse probably weighs somewhere in the range of say 1,000 to 1,500 pounds, more for draft horses, less for Arabs and small, ponies and things of that nature. But, obviously, the missing letter makes a big difference, right? In the what happens at the other end. Am I asking for an 81 milligram aspirin, or am I asking for a 15.6 gram aspirin, right? As mentioned, I think in our basic traffic handling courses, is why we recommend that these terms be spelled out. MILLIGRAM, for example, etc. So errors like this don't occur. So these are some ways in which you can test the ability to perform the entire communications process. We want to test the human side, the human interface, look for human errors, okay? And we want to test the technology. But always understand that technology is a medium, okay? Communications is the entire process, okay? Furthermore, whatever exercise you design has to meet these requirements. It has to be realistic, okay? The results have to be measurable, and the goals must be attainable. You don't want to set your MCOM group up for failure. You want to design an exercise that takes into account your limitations, right? Say, you can't expect us to replace the internet, for example, and attain the same level of convenience and circuit capacity, bandwidth, et cetera. So all exercises must be realistic. They have to be attainable. They have to be measurable. Okay, and ultimately, our goal is the timely and accurate delivery of messages. I don't care if you do it via cellular data network, landline telegraph, carrier pigeon, or WinLink, but accuracy and timeliness are going to be critical in the disaster telecommunications process. So again, test the whole process, and when you design your exercise, make sure it's realistic, measurable, and attainable. Okay, and really, it doesn't. Don't put so much emphasis on the medium. The medium is what you have available to work with, and pretty much any medium can be used to deliver an accurate and timely message. Okay, so there's some examples here. The press telegraph operators at the infamous Longer and murder trial there in New York City in 1943, and then of course some soldiers in World War II using carrier pigeons. So, but they worked. So what we did basically is in developing or designing the cascading arising exercise, the very first thing that we wanted to have was controlled inject messages. Okay. So in other words, we wanted messages that were already formatted, all ready to be injected. Okay. So that we had a control to compare the output against. And so in other words, our control was the inject message, our variable was the output message at the other end of the network. And in doing so, we can compare the controlled inject message against the message at the output at the other side of the network to create an accuracy measurement. So we also wanted each radio operator to maintain an appropriate net continuity log in which he recorded when he injected a message, at what time the messages were relayed and to whom, or when the messages were delivered. Okay, so we could trace a message through the entire communications process. Now, you don't necessarily have to go to this detail, but we did because it was a national level event. And of course, there was a lot of geography involved, but we literally had every participant return a log. And I'll show you an example of one of those logs in a future slide here. But the idea was that we could, number one, measure the accuracy of the controlled inject against what came out at the output side. We could see how long it took a message to propagate through the system. If messages disappeared somewhere along the way or there was a delay, we could identify where that delay occurred. Was it a technical problem? Was it a radio operator error, etc.? And we had a couple of cases where it was radio operator error. And we had some problems that were related to propagation that we identified because we logged the process at each relay point, at the inject and each relay point and at the delivery end to arrive at these values. Okay. And so, we were able to identify failure points. We were able to measure message propagation time through the system. We were able to measure accuracy. Okay. So what we did is we provided pre-formatted messages and guidance documents to identified participants in the states involved: Alaska, Idaho, Northern California, Oregon, and Washington State. The messages were properly formatted in a standard radiogram format with appropriate accountability, all the necessary network management data in the preamble, and a date time group. For the purpose of this exercise, we had ran into a lot of kind of unfortunate and nasty politics in one of the areas. I won't mention the state, but we had a section emergency coordinator, and he really objected to the participation of NTS, and he refused to cooperate in any way with FEMA. So we had a conference with the officials in Washington, D.C., and we came up with an alternate plan that what we would do is we would create messages that consisted solely of 5-letter cipher groups. Now, these were not encrypted messages, but rather they were circuit test messages. So in other words, the cipher groups didn't represent intelligence, but what they did is they tested the accuracy and skill of the radio operator. So all the message text consisted of 5-letter cipher groups. This allowed for a hermetically sealed exercise that was isolated from I hate to say it, but the not necessarily uncommon politics that arises and disrupts many amateur radio activities, kind of that petty infighting and power and control issues and the like, and allowed us to conduct an exercise that was somewhat isolated from the local ARES activities. We also, in many of these 5-letter cipher groups, we introduced little errors that were unannounced to the radio operator. So, for example, there were some messages with 6-letter cipher groups. Not a lot of them, just one would be dropped into an operator's group of messages. We would occasionally create a counterintuitive date-time group to see whether or not the operator, the operator would respond to that, right? Then we took all of these messages and we placed them in sealed, date-time stamped envelopes, indicating the time they should be presented for origination, okay, or injection into the network. And so these messages were put in these sealed envelopes, a stack of sealed envelopes, and then they were tendered for origination at the time specified on the envelope. So, for example, this message would be originated at 1312 Zulu, 1312 Zulu. The radio operator takes it, opens it up, transmits the message either via the digital traffic network or one of the CW primary entry point frequencies or a voice frequency, and it goes on its journey to the National Response Coordination Center. So this is what a typical packet looked like, right? So you can see here, we created a set of operating guidelines. Basically, here's the procedures. The prototype national response plan. We created an exercise plan describing the rules for the exercise and how it will be conducted. We provided a set of message logs. And then, of course, we provided the sealed messages and envelopes. And here's a couple of examples in the slide. And these were all provided in advance of the exercise so that we had complete control over what was injected into the network. Okay, and this allowed, again, control. Okay, as mentioned, we then, let the network do its thing, right? And this was a grid down scenario, so messages can only be delivered upon reaching the destination delivery point. The route was entirely RF from the Pacific Northwest in Alaska to the National Response Coordination Center. And again, we were interested essentially in what happened when those messages arrived and were delivered from the 3RN, third region, okay, which would be the Philadelphia area. Okay, so Philadelphia area was where the messages were received and then injected into the data stream at the National Response Coordination Center. And again, as a control, we made sure that the radio operators performing this function had the necessary skills, right? We wanted operators who, basically at the delivery end, we knew would be competent to do the job, serve the agency, and not introduce unwarranted errors before an appropriate measure could be made of these various factors: accuracy, message propagation through the network, et cetera. So we did carefully vet the delivering operators. Furthermore, today we call these operational readiness messages, but each participating radio operator was required to originate an operational readiness message. And essentially what we did is we assigned a network coordinator. The network coordinator received all of these operational readiness messages, and he created a spreadsheet identifying at any time during any of the three phases of the exercise what stations were active, what specific served agencies and officials with whom they had contact, what frequencies and modes were available to them, or the particular communications unit with which they were associated, and identifying any operational limitations that they might have. Okay, this was all entered by the network coordinator onto a, you might say, a dynamically available spreadsheet, where, for example, if FEMA wanted to send a message back to the disaster area, we could send that message back. Okay, and we could route it using the most expeditious network methodology to get it to its served agency destination. Okay, so say an official came to me and said, we need to send a message to Seattle, Washington. Okay, we can look at that modified ICS 205 spreadsheet that the network coordinator is maintaining based on the operational readiness reports from the field. And we could say, okay, we have W7LVB available. He's on this particular net. he's utilizing these modes. This is the most expeditious way to get a hold of them. We'll put this in as a priority message or an emergency test priority or test emergency message and expedite it to its destination. So that's the purpose of that network coordinator function. Okay. And in the exercise, we call them a network manager. Today, we call them a network coordinator. Okay. But again, his job is to maintain a database of operators, their connectivity to various local and state agencies, the frequencies at which they're operational, for example, the nets at which they're operational. And this allows us, when necessary, to route traffic using the most expeditious methodology. And furthermore, we ensured that the network manager, again, as we call him today, network coordinator, was located off-site. He was neither at the NRCC, nor was he in the simulated disaster area. We wanted him to be in some disaster benign area, like Ohio or Michigan or, someplace, in this case anyway, where, he can deal with this, or he can have several guys from his radio club or his Aries group, deal with this process without worrying about, the hub, the whole, the whole environment of being in the EOC or in the disaster area or whatever. So it worked out really good. It was an excellent process and highly recommended for that. Now, as I mentioned earlier, we looked at measuring accuracy, right? So we decided that we needed an analytical methodology to not just score, but to determine failures. Okay, so a good analogy might be land surveying. I know any of you guys have ever been around land surveyors or done land surveying, but surveyors have an expression that errors occur, but blunders shouldn't. So an error is when you go out to do a survey and maybe maybe the witness post is an inch off where it should be. That's error. Okay. When it's 20 feet away, that's blunder. Okay. And so, error and blunder are two different things, in land surveying. So this is sort of a similar type of thing. We wanted to look at each message. We wanted to have a scoring criteria that was objective. Okay. And we wanted this to take into account not just the quantity of errors in those 5-letter cipher groups, but whether or not the pattern of those errors would determine whether or not a message was fatal or non-fatal. So what's a non-fatal error? It's maybe where somebody, my name is Whiskey Alpha Delta Echo Sierra. Well, if somebody addresses a message to James Wade, Whiskey Alpha Delta Echo, okay, that's kind of a non-fatal error, right? That's easily managed in the EOC environment. If you call somebody, a staff sergeant instead of, first sergeant, sergeant first class, okay, not necessarily a problem, but you may have other things like asking for the wrong quantity of supplies, etc. But since we had to create this hermetically sealed exercise, we wanted a criteria for determining whether or not a message might be a fatal message. That is, it's not understandable, it's significantly garbled, there's other major errors, or whether or not it was a non-fatal message. Okay, and so again, we wanted to also note any connectivity failures, delays, and outliers. So this was the grading scheme for the cipher groups. And again, you don't have to use this methodology, but it points out the fact that you need to have an analytical process to score your group's performance. So the very first thing is we treated each letter or figure within the radiogram as originated as a unique data point. Okay, so any error in those 5-letter cipher groups or in, the signature, etc., would be considered a distinct error. So if the cipher group is GRPYZ and the radio operator copied GRPYO, the missing of that one letter would be a single error. Okay. Up to 3 errors within different cipher groups were treated as individual errors. Okay. And these, of course, were scored. And any 4 or more errors within an entire message was treated as fatal errors, and the message was discarded. Okay. In other words, that message is, it's the same as a message not arriving. Message was considered garbled. 2 errors within a single cipher group were counted as 5 errors. Well, what happens with 5 errors, right? 3 errors within a single group were counted as a fatal error as well. Okay, and the message was discarded. So we allowed for minor errors within the accuracy methodology, measurement methodology, but we also tried to come up with an analytical method that seemed reasonable. Okay, for determining whether or not an error or group of errors, small group of errors, were fatal or non-fatal. Okay, and this was the grading criteria that was ultimately used. Now, you don't have to use this specifically, but this is in keeping with a lot of, say, professional engineering methodologies, and the like. You have to have some kind of scheme to determine whether or not the message was a failure. Now, in plain text messages, which is probably what most of you guys will be doing in your exercises, what's the obvious critical things? Your scientific nomenclature, say if you're requesting say medications of a certain type, whether or not the spelling of the medication is correct. You can probably come up with a lot of examples as grading criteria for plain text messages. So if we took a message like this, we would, of course, operator would, the message is tendered for origination. It's transmitted to the NRCC. It's in the form of 5-letter cipher groups. And then the message, of course, is delivered. In this case, it was delivered on standard, ICS 213 type format. Okay. And so, these were the one in the upper left-hand corner here as this originated. Then, of course, this is the message that was scored. And we looked for any differences between these 2 messages. Okay. We also looked at the radio logs, which allowed us to measure propagation times. And so, for example, this is from AL7N in Alaska, Fairbanks, Alaska. This is his log. Okay. He received traffic on a peer-to-peer WinLink digital network. And because of the distances involved, 2,300 miles, as well as propagation anomalies and so forth, as you near the Arctic Circle, all of the traffic was transferred to a point-to-point high-frequency radio telegraph circuit to Washington State. And then from there, it went via the radio telegraph IATN circuits for delivery in Philadelphia to the National Response Coordination Center. Okay, so essentially, HF point-to-point digital to the gateway. The gateway transferred the traffic to radio telegraph mode, and it stayed on radio telegraph to the NRCC. Okay, and so this is just a typical example of a radio log. We had a big stack of these to go through afterward. Okay, so let's talk a little bit about the accuracy measurement and what the outcomes were. The Alaska Interstate Backdoor Network, which of course was a smaller amount of traffic, less opportunity for error, scored 100% accuracy. So the Alaska radio operators in the interior of Alaska, that is the section level, did an excellent job. Then, of course, the Digital Traffic Network scored 99.997% accuracy. And I think that I should have put against the number of data points here, but I seem to recall it was around 8,000 data points. So the Digital Traffic Network scored about 99.997% accuracy against somewhere around 8,000 some odd data points, I think. And the combined radio telegraph score was 99.998% accuracy against, I think, somewhere over 13,000 data points. One of the takeaways is that voice methods were not used beyond the state level. And therefore, there was nothing to measure. And the reason voice methods were not used is because the propagation conditions were so poor at the bottom of the sunspot cycle, and it just happened to be a really bad propagation time when the exercise was conducted, RF propagation time. that it wasn't practiced. Nobody could communicate on single sideband, so it was never used. It just didn't have the, let's say, the resiliency to deal with the propagation conditions. So pretty much everything moved by voice and or I should say by digital and CW. Again, pretty interesting results here. Now you might say, well, why did the digital traffic network score lower than the combined radio telegraph? Well, an accountant will tell you that 99.997% versus 99.998% is a de minimis difference. Okay, but if you want to dig a little deeper into it, one of the dangers of digital communications is that you can have data entry errors. Okay, and the interesting, kind of odd thing about radio telegraph message handling is that the radio telegraph operator is essentially proofreading the message as he transmits it. And the radio telegraph operator will often notice potential errors and inquire about whether or not they are errors in the process of transmission and reception, because every message is essentially being proofread. Okay. And so ironically, the CW net scored a little bit more accuracy than the digital traffic network, which of course has automatic error correction. But I point your attention back to the fact, garbage in, garbage out. And this is why, if you read the latest issue of Q&I, where I talk about setting up a message center, a great tool to have in the message center, it doesn't have to be a ham operator even, is a message clerk. Somebody that proofreads messages before they're transmitted, makes inquiries with the functional representative in the NIMS process or EOC process to say, hey, does this, I just want to make sure you meant to say millibars here, and, you meant milligrams and not micrograms, or, whatever the case might be. So these are all, issues that can arise in either an exercise or in a real disaster. Propagation times. The average message propagation time for the combined process was about, for CW, was 30.5 minutes. However, this message was message propagation value was skewed upward due to what we identified as a couple of human errors. For example, we had a couple of operators who misplaced messages. They got a little bit, confused. They missed a couple of messages, and this resulted in a delay, for example, in one case of 110 minutes. If you remove those 2 or 3 outliers, the average message propagation time changed to 10 to 15 minutes. That is from the time a message was tendered for origination in the disaster area to when it arrived in the data stream at the NRCC. One message propagation time measured at 1 minute. So there was some pretty impressive radio operating going on there. The message here is not that radio telegraph is better. It's that really the message is that skills, okay, and experience are of great value. Okay. Again, the mode is just a medium, whether you use, a highly skilled CW operator or a good voice operator, or a digital, it's really the human element sometimes that really makes the difference. Okay. That should probably be the takeaway here. We kind of talked about this, again, in terms of the Alaska intrastate network, it was a digital backdoor network. Okay. But because of the length of the circuit, the messages went to a CW gateway, and then basically from there, an approximately 2,000 mile circuit to Washington State. And then I don't know how far it is from Washington State to the Washington, D.C., Philadelphia area, but it's probably another 1,700 miles or whatever. My geography could be off a little bit. Good score, from Alaska as well. The digital traffic net had some problems. We learned a lot about the digital traffic network. Again, very poor propagation. And what we found out was the average message propagation time through the digital traffic network was 82.4 minutes. And why was that? Well, here's some important takeaways. The very first thing was there was a lot of co-channel and adjacent channel interference. So many Aries groups were using the shared narrow slices of spectrum with WinLink that there were often long delays due to carrier detect holds. Okay, and this is the message you guys need to think about a little bit, and that is you need alternatives. I think one Aries operator described it to me as it sounded like a contest. So a lot of these modes, particularly WinLink and so forth, have automatic carrier detection. You guys have all seen that, and that resulted in some delays. And the takeaway as well is that those delays may not have been related to message priority, right? Test emergency, test priority, test welfare, etc. So keep that in the back of your mind. Another problem that we noticed is that a lot of well, of course, in the digital traffic network, the nodes are set up to be non-directional. Okay, so these non-directional nodes, they typically operate at 100 watts using non-directional antennas like dipoles and so forth. And there was no real flexibility for targeting the disaster area. So whereas the radio telegraph operators, some of them who had beams and things of this nature and amplifiers could go ahead and target the disaster. You turn your TH6DXX, or your tri-band beam toward your log periodic toward Washington State and or Alaska, and you've got yourself a much better circuit, right? You might have 5-6 dB difference. That flexibility that manual methodologies have to dynamically respond to propagation conditions proved to be a big advantage for CW. The moral of this story is that when you design your disaster telecommunications response plan, don't put all your eggs in one basket, be it WinLink or DTN. Make sure you have alternatives available because you don't know what's going to happen. But the delay associated with a message propagation time of 82.4 minutes is probably not acceptable. Okay, so we in subsequent years we looked at ways that we might be able to better target a specific disaster area under the National Response Plan. And keep this in mind too. I mentioned in I think the emergency communications planning class, the value of having what's called an order wire. If you got say 10 or 20 Aries groups in Oregon that all want to use WinLink, you need to have a way for an order wire net, maybe on 40 meter single sideband where say, hey, I have 4 emergency priority messages and I need a circuit right away is 710.1.5 in use. We're using it currently, but we'll abort over, that kind of thing. So again, another thing, deficit that we noticed was that there were no manual sysops present at the DTN hubs. We did this by exercise design, but in a real disaster, we learned that DTN operators, if possible, have to be present to monitor the performance of the various nodes and hubs in the mesh network and say, okay, am I getting throughput? So again, the 82.4 value was related to what would happen if the DTN was just set up as the way it operates routinely. And it didn't work as well as we had hoped, but it still got the traffic through, but just not as fast. And this is the message propagation, or I should say our propagation conditions on the days of the exercise during phases 1 and 3. You would see conditions were extremely poor pretty much throughout the entire HF spectrum. And this did have a negative impact on DTN performance, but interestingly, not so much on CW. This might be a little hard to see, but this is an example of the metrics from the evaluation report. We were able to identify every message based on date time group, station of origin, time of origination, mode used, time of arrival, arrive at a value for, propagation through the network. And, all of this was available on a spreadsheet for FEMA at the end of the exercise. Okay. So let's talk a little bit about some of the lessons that we learned. As a matter of fact, before we do that, I see there's 3 things on chat. Oh yeah, a couple of people were talking about links. I just wanted to make sure we didn't miss anything there. Let's talk a little bit about lessons from the exercise. So first and foremost, and this is, I've seen this lots of exercises that I've designed, not just radio communications things, but actual things like, bioterrorism exercises, counterterrorism exercises, other types of disaster exercises. Skill and experience is the key to success, and certainly is for radio operators. You cannot take an Aries volunteer and hand them a ICS 213 message or a radiogram ICS 213 message or whatever, and expect them to accurately transmit or receive communications traffic. This is not going to happen unless he has some experience handling traffic. It's just that simple. I designed a big exercise. I think there were 13 counties involved in a big bioterrorism exercise some years back. And I tasked the amateur radio group with just a very small set of tasks, the Aries group, one of which was to receive a message containing etiological information from the State Department of Public Health. And, of course, we used a similar methodology, controlled messages from the state EOC to be received at one of the county EOCs. And the radio operator confused, he transcribed the message as identifying the disease as bubonic plague. But in reality, the disease was pneumonic plague. Okay. So, this is what happens when you don't know how to say mnemonic. I spell Papa, November, Echo, Uniform, Mike, Oscar, November, etc. Right? And you rely on assumptions and the like because you've never handled traffic. And so, this is why we encourage traffic handling and this type of thing. It's because it teaches you how to implement those basic radio telephone procedures, how to record from whom you received a message and to whom you sent it, and all these other valuable things. Okay. So radio operator skill and experience, played a major role. Diversity of modes was essential to an effective disaster communication strategy. Manual modes proved more effective, not because the mode itself was necessarily superior, but due to the fact that the ability of the operators to respond dynamically and in real time to different communications problems, co-channel and adjacent channel interference, poor propagation conditions, et cetera. And ultimately, common denominator modes offered versatility and universal access, right? Even with digital backdoor methods being used in Alaska, it was radio telegraph that handled the long haul circuit. So there's no mode parochialism there, right? We don't have to say, we went through a whole debate in ham radio, back in the early 2000s where people were screaming at each other and engaging in all kinds of childish ad hominems, about how horrible CW is. And, nobody should have to learn it. It's a 100-year-old, technology, blah, blah, blah. No, a CW is a tool. And it's also, it's a method of input and output, but the medium is often conveyed by software-defined radios, right, that are very high tech. And, it's really, it's a versatile mode. I'm not saying everybody should have to learn it, but we shouldn't dismiss modes and methods and networks because we have a certain bias, you might say, toward a certain methodology, or some guy that has very little experience in emergency management and disaster response says, well, this is the way it is. Well, okay, how do you know that? Is your information peer reviewed? Are there exercise results to indicate, justify your opinion? If so, how were those results attained? Were they, were those peer reviewed? Were they analytical? Were they designed to be unbiased? These are all things that you need to consider in your emergency communications resource management decisions. Okay. Essentially, modes like DTN and WinLink are less agile, right? I mean, typically you're using specific frequencies. You have very little control over demand for those frequencies. You can't move the node that you're trying to connect to if there's a significant co-channel or adjacent channel interference, right? Certainly, for at least our digital traffic network at RRI, we now know that a SysOp really needs to be present whenever possible at hubs to monitor performance and message throughput. We need to have the ability, if possible, to target disaster areas with a directional antenna, maybe an amplifier, etc., and reconfiguring that network slightly to provide a thing, or just to have more hub diversity, right? Instead of maybe having one hub serving a region, we might need to have 3 or 4, and we may need to have a few at the state level. So we need to look at our plans, to deal with that. That was an important lesson learned. Okay, but ultimately, experience played an important role. I mean, if you look at the background of the participants who handled the communications traffic, we identified a lot of professional experience. We had quite a few guys that served in the Army Security Agency, the U.S. Navy, former maritime radio operators, radio amateurs that had extensive, daily experience in CW traffic handling. Again, it's easy to misplace a message when you're confronted with large quantities. Again, read the Message Center article in the most recent issue of QNI. Good administrative skills are essential to success, and certainly are a methodology to eliminate these potential fatal errors or lost messages. And of course, there is a place something to be said for multi-operator facilities that are located outside the area. And that's the way we handled the interface with the NRCC, right? We put operators in a place where all they had to worry about was radio operating. Okay, didn't have to worry about the disaster, didn't have to worry about getting involved in distractions. And of course, what we need as radio amateurs, quite frankly, particularly on the traffic end, is a greater depth of radio operators. We need more traffic handlers. We need more guys that are interested in doing this type of public service communications. We can't always rely on the same guys. So essentially, there's a few other things too. I mean, high frequency radio is experiencing renewed interest in the military and in emergency management. And obviously, we should be placing renewed emphasis on it in ham radio. Back in early 2000s, I had an Aries, I think he might have been section emergency coordinator. I won't tell you in what state. Call me a quote freaking moron for arguing that high frequency radio had value because it was the most survivable communications method. So on this this big national list, he called me a quote freaking moron. Obviously he was an expert, but anyway, again, look at your networks, engage in that hazard and vulnerability analysis that we discussed, apply the emergency management cycle to mitigate the effects of disaster, understand the role of survivability, flexibility, circuit capacity, and security. The exercise certainly played that out. So let's go to questions. How did I didn't do too bad. I did an hour and a half on this. And so let's open it up to some discussion. Did I put you all to sleep? Hello, hello.
Actually,
we are here.
congratulations. That it was a very good presentation. Appreciate it.
Well, thank you. I appreciate that. Any questions or comments or insights that others would like to offer?
James, this is Dan, California.
Hey, Dan, how are you? Long time no see.
Yeah, well, I've been keeping my head down and getting some work done. So I'm the first to admit that all emergencies are local, and therefore disciplined local nets are essential. And then my understanding and comprehension of what RRI's architecture is kind of dissipates into, whoa, wait, here we are, it's 2022. I think one of your own slides mentioned that Alaska's in-state backdoor network had 100% reliability. And that capability, if you pay attention to the live WinLink backdoor gateways, is probably vastly expanded throughout the rest of the country, et cetera, et cetera, et cetera. And it's not clear to me whether this was you said it was a 2016 exercise. Was that right?
That's correct. June of 2016. Mm-hmm.
Okay, so 6 years ago, it was a phenomenally well-structured exercise. Today, it's unclear what the goals of the exercise would be today and who the national served authority would be and where RRI fits into the DHS mandated PACE ESF2 layers.
Right, right. So, essentially, we see ourselves as an infrastructure provider. So the analogy we like to use is, okay, so you're of a certain age like I am that you remember the local Intralata Bell operating companies, okay, and then you had AT&T long lines, right? And so most of your calls in progress were Intralata or local calls, right? And then of course you had AT&T handle the long haul messaging. Well, WinLink and RRI are sort of similar in structure. Certainly RRI is to the phone company. So you got a section net, right? Section traffic net. Section traffic net might be providing connectivity to your state EOC, and might be performing some functions within the state. Maybe the region net picks up some, handles some traffic being exchanged between states. And maybe if FEMA needs communications, I imagine they have probably don't need ham radio for a lot of this stuff, but let's say you do need to get a message out to different states. Welfare traffic, for example, would be a good example. What happens if these cellular data networks are down, say in the Cascadia Rising subduction zone, and you want to originate a volume of communications traffic. So for example, I don't know what year Hurricane Maria happened. It's a couple of years ago, but one RRI operator alone handled over 2,000 messages, welfare messages out of Puerto Rico. I was driving down I-55 in Western Illinois, and I got a call from the American Red Cross headquarters. They needed to get a message into Puerto Rico. And I got up on one of our priority entry point frequencies. I pulled over on the side of I-55, transcribed the message, put it on a priority entry point frequency, and it went to Puerto Rico. It's interesting. You can, again, it's an open infrastructure, right? Whatever you need it for, it's available, and we can't always predict what those needs are going to be. Oh, I can't hear you. Are you muted?
I'm muted because the dog was arguing with me that I should be feeding.
Okay.
I disagree with you wholeheartedly. I think SHARES needs amateur radio operators who are trained and qualified to serve their local authorities with data that they could then, with confidence, submit through a level of HF mesh networking employing ALE and other technologies to have, I won't say always 100% assured throughput, but certainly highly reliable throughput.
Mhm.
So training in the discipline of operating systems, and in fact, you mentioned something that sent a shiver up my spine, which is as amateur radio operators are transmitting the messages, they're proofreading them. That's just not a good thing to think about in a national scope disaster.
No, that wasn't my point though. My point was that the if you're going to enter data into, say, WinLink, okay, say you're writing an email, okay, you should proofread that before you send it. So what I was explaining is why the radio telegraph net had a slightly higher accuracy score. It wasn't that that was the preferred method to do it. It's the fact that there is a tendency in all of us when we type a message into an email or say the window there in WinLink to send it, to hit the send button, but there needs to be a process to ensure accuracy before you hit the send button. That's my point.
We don't have the luxury like I do of spending 45 minutes reviewing a 6-line email. I want to send for maximum.
It wouldn't take 45 minutes. See, that's why, you know,
45 minutes. It takes me 45 minutes.
Well, no, that's why you have to have a process in place. So if say you're tasked at an emergency operations center, okay, you need to think about this before the disaster and have a methodology through which, you know, ensure a methodology is in place to ensure accuracy before messages are sent.
If I'm at an emergency operations center, I'm not a radio operator.
Mm-hmm. No, but radio operators are at EOCs, aren't they?
Well, I suppose that depends on the emergency management agency running the EOC, but it's
Right.
not a best practice.
Well, it's also, but it's a common practice. You know, you often have a message center associated with an EOC. Maybe the dispatch centers next door.
Even a room with a soundproof door adjacent to the
Well, right,
EOC.
absolutely. Yeah, absolutely. Yeah, absolutely.
Okay.
I mean, but somebody's bringing you a message or it's coming electronically to your operating position, right?
Well, and that's the point right there, is if they're coming in with a handwritten message and giving it to me, I'm not being utilized properly. It should be being handed off electronically in whatever form they use it natively.
Yeah, that's true. And what happens if you're standing out in the field with an official? Okay, so, you know.
Well, once again, if you look at the rate of accretion of surprisingly functional WinLink templated forms,
Mhm.
if you're standing out in the field with them, you're doing the same thing.
Well, yeah, but you might not have
Put
WinLink
the laptop
available.
in front of them and they type the 213.
That's possible. Yeah, absolutely. But it's not necessarily always the way things are going to work. That's my point. You know,
Well,
radio operators should have the flexibility. And my point is you need to have the skills.
What we have
Okay.
is we're ubiquitously dispersed throughout our nation's population.
Right.
And we subscribe to MacGyver as valid technology. And we
Mhm.
make things work when formal systems never could. But that gets past local. And I think I don't know what we're trying to accomplish at that point.
Well, here, you know, number one, you know, let's start with the basics. Okay, you know, the government agencies have a whole range of professional systems with which they use. We're the tool of last resort. Okay, people are not going to be coming to agencies aren't going to be coming to us to handle priority and emergency messages unless there's a very serious. You're in a very serious and probably precarious position. Okay, you need to have the ability to handle any situation. If you're in a nice controlled environment, okay, that's great. You maybe do everything electronically, and maybe the served agency official has time to walk up to your computer and type in his message. That's entirely possible at the incident command post. On the other hand, what happens if you're standing out in the field with a service agency official and all you have is a handheld radio and a write and rain notebook and, you know, some paper message forms? Okay, whole different animal. Okay, so the point here is that you need to have the skills to handle pretty much any kind of circumstance. And I think it's really easy to try and imagine that, you know, we're all going to be in this neat little box, you know, ESF this, ESF that, RDO this, RDO that. And it's not necessarily going to work that way in a truly catastrophic disaster. Ask the people in Puerto Rico, you know, how things work.
I live in a county that has a 2-person Office of Emergency Services.
Right, right.
And, but yet and still, they would be the ones I'm responsible to, including whatever amateur radio resources in the county are available to do any of this. And that's why I think the local traffic nets, and actually single sideband voice, I think if you can't do it with voice, you probably can't do it right any other way. So just going back to the standard radiogram as a prerequisite to learn how to accurately and concisely convey information is the essential basis on which we can be useful wherever we are.
Well, right. That's my whole point. And, you know, we put in all these training courses is that,
Turning
you know,
that into a national exercise with indefinite authorities at the National Coordination Center and in the field is just an anathema to having, you know, an orderly, effective, efficient implementation of the A, C, or E in PACE.
no, the sole purpose of the test, was to measure the accuracy and the capacity of the network itself to convey message traffic accurately on a timely basis. We weren't testing we were not testing the interface at the local level in the way in which you described. Okay.
But were we testing the amateur radio operators' abilities to affect this sort of independently?
We were testing the network. That's correct. That's what we were testing. You know, RRI is, for example, is an infrastructure provider. Okay. How the interface occurs at the local level, that's up to the ARES or Oxcom group. How you inject the message. Yeah, I'm gonna use the mode that I have available. Now, the example I used was the message to Puerto Rico, right? The mode that I had available was a high frequency radio sitting on the passenger seat of my car. Okay. And a key. Okay. I used the best tool at that moment for the communications job at hand. Okay. That doesn't necessarily mean it's the only tool.
Everything you're doing is okay. I'm just questioning where the dividing line is between a training environment and what happens when the sky is not blue.
Well,
and I don't think trying to fit the paradigm of a multi-layered network where there's more than, say, one intervening goes into and goes out a device is just an anathema to modern communications, even at the hands of amateur radio operators.
I guess we're arguing circularly. I don't understand. We tested the digital traffic network, which is a modified hybrid mesh network. We tested voice and we tested CW. Okay. And we had measurable results from that. And, I've responded to disasters and not everything's neat and clean.
Well, nothing's neat.
Well, right. So, how I inject them.
And I think there's some confusion because, there, especially in 2016, FEMA and DOD and Mars, et cetera, had different agendas. And in order for success to prevail, I think nowadays everybody recognizes we need to be reading from the same playbook.
Well, we've been working with, we've, so Bill Thomason says, yeah, Vero peer-to-peer will work. Absolutely. I mean, there's all different kinds of tools available to us. No, we've been working on ongoing exercises with our Army Mars Region 2 now for several years at RRI, where they inject messages into RRI, it propagates through the RRI gateways, and then they're delivered at the local and section level. I mean, that's part of the process, right? That's why we have networks, and that's why we have methodologies, and that's why we have
As an enhancement to Army Mars, what you're doing is spectacular.
right. And we're not here to do everything, right? I mean, we're here to do what we can. We're not the Army Signal Corps, or, the Air Force Communications Command, or whatever it's called these
No,
days. Right?
I don't mean to be troublesome. I respect I respect everybody involved in RRI's integrity and their personal commitments.
Mhm.
And I'm just hoping to sort of be the guy that pokes and prods and says, "Hey, stop for a minute and look around."
Uh-huh. Well, the purpose of this
But-
class is not to really argue about RRI or its place or its relationship to FEMA or anything of this nature. The purpose of this is to talk about how you design an exercise, and the fact that communications is more than establishing connectivity, that you have to have an objective and measurable process in place. And this serves solely as an example. It's not here to tell you how you have to run things in your county. I'm not here to tell anybody here how to run things in their county. I'm simply giving you an example of how we designed an exercise to prime the pump and get people thinking about the fact that a disaster communications exercise is not just simply saying, okay, well, I sent Joe WB8, SIW to the fire station and we established connectivity, exchanged a couple of tactical messages. That doesn't necessarily measure your ability to do that. Setting up, as I think Mr. Thomason said, setting up a point peer-to-peer Vera connection, and making sure the traffic is handled accurately, expeditiously, and properly serviced, and so forth. That's a measurable and attainable exercise goal, and that's what we're talking about here. Okay, and quite frankly, let me add one other thing too, and I don't mean this to be combative in any way, but neither RRI nor amateur radio exists solely to serve the government. Okay, if my neighbor comes to me or my local community has no communications and my neighbors want to send welfare traffic out, or they have even a priority situation, they may come to my house. My tool might be maybe a QRP CW transmitter, right? I'm not here just to serve, none of our networks are here solely to serve government. Government's a priority customer. I get that.
Rule number one for any responder of any kind is self and family first.
Right. I mean, and I've got neighbors. I've got, a lot of us have communities in which we're involved. Some of us may be involved in small local volunteer organizations active in disaster response. We have this, don't get me wrong. I think it's really important for, Aries and Oxcom, obviously, to play in the same sandbox and, do all the right things. But not every radio amateur is going to be involved in those things, right? I mean, so we don't exist solely to serve government. We exist to serve any viable emergency communications need.
I think we agree wholeheartedly that our highest value is that we are sort of ubiquitously dispersed in the population,
right?
Which means we will be able to communicate, and that's what we'll do after we tend to self and family after any kind of disaster.
Mm-hmm.
And you see it repeated over and over all over the place, no matter what's going on. And focusing on, how do I say it, simple training that will expedite accuracy, timeliness, and measurable results. And there's not much more measurable than a WinLink message which is, tracked from beginning to end
Yeah.
and retained for, I think it's a 14 or 21 day period.
Well, I wasn't,
for-
well, the WinLink's a great program. I'm not putting it down. I'm just suggesting that, you
And I'm not holding it up above any other effective digital means. It
That-
just
that
happens to be.
yeah, and that's fine. I'm just suggesting that, you need to have alternatives as well, because I can walk into any amateur radio station in the world and I can pick up a microphone and talk. Right.
Correct.
Okay.
Absolutely.
And this is why RRI has a course on basic radio telephone skills. And this is why RRI has, these basic courses to understand these things. I think somebody here is raising their hand. Cindy, yeah, go ahead, Cindy. Yeah.
Yeah, kind of back to the purpose of the class. I might have blinked and missed it. After you had analyzed your results, what did your after action look like? Did you guys make any changes to your process based on what you observed, even though you had such high accuracy of your transmissions? Did you change any of your processes? Did we cover the incorporation of after action stuff?
Yeah, the report, the evaluation report is available on our webpage. But yes, we did. We made actually since then several revisions to our what we call our National Emergency Communications Response Guidelines, kind of what we refer to as the National Response Plan. So, for example, since then we worked with the WinLink development team to develop the radiogram, I'm sorry, the RRI WinLink gateway process and the standard radiogram and radiogram ICS 213 templates. Obviously, the welfare radiogram template that was recently developed. We've done multiple communications exercises in which we've learned smaller lessons. We did a Navy medical exercise. We participated in some other exercises with Mars.
I was just making sure that, you did the whole loop thing there. So thank you very much.
Right. Yeah, you should always follow up, afterward and trying to make the necessary changes. And of course, obviously, we're trying to improve training and, operator depth and, introduce new modes and methodologies to solve some of the problems that we identified. The biggest problem for all ham radio groups is finding people to do the work, obviously. Christine, you had a comment here, which I think is really important. Are you still on? Christine, K4 KJN.
Yes, I'm still here.
Yeah, I thought you made a really good point. So I'd like you to about these very technical counties versus limited technology counties, because this is something I've seen a lot of.
Do you want me to comment?
Well, sure. It's your thought, not mine.
Okay. Well, I'm kind of a newbie. I'm just a new section emergency coordinator, and we're setting up an exercise based on cyber attack. So we are going to eventually keep cutting down what we have to work with to see how much we can get done with very limited resources. But like I said, in some of my counties, they don't have a lot of ability. We did a survey and found the only thing that every county had in common was 2 meter 440, which is very limited capability. So I've set trying to follow ICS. I only have 10 counties in my section, so I put them in groups of 2, and then I only have 5 inputs to look at. And then each one of those, I have some that won't take a lot of work and others that are going to need some help. So I've kind of paired them together so that counties that can't get to, say, an HF portal to get information will be with a county that can get information to them in another way. And we have a big group of NXDN people. And then in other counties, we have a big network of DMR folks. And so we're trying to coordinate all that and get every person in our section to be in contact so that we can get information from every county into state during an emergency.
Right, right. Well, this is something I've observed over many years, and that is there is a wide variation in the skills, capabilities, and even activity level of Aries groups. And it's nice to say everybody should use WinLink, but like you said, there's some counties you go into, and you'll be lucky to get somebody that can do HF single sideband, or you know, and then you run, like you say, you run into kind of this mode parochialism. So as I think I mentioned in another class, one of the beauties of having common denominators, for example, 2-meter FM is a common denominator. It used to be that I knew that if I was deployed to, say, Southern Florida or the Pacific Northwest in a disaster, if I had 2-meter FM capability, I knew I could talk to the local Aries group and intercommunicate. I didn't necessarily have to have a specific digital voice mode or whatever. There's much value in these modes. So during Cascadia Rising, we tested common denominator HF modes, voice and CW, because you don't know what you're going to encounter, what the Aries group has, and that's an excellent point that needs to be made. I'm a believer, and have been for many years, that Aries groups need to create consortiums. In other words, what we need to do is say, okay, my section has, we've agreed on, these are the baseline capabilities that an Aries group needs to have. Okay, doesn't need to be the whole, panacea of the emergency communications capabilities, but here's certain baseline capabilities. And if they don't have one of those capabilities, and so you're thinking kind of like I think I do, let's pair them up with another Aries group, or create kind of a mutual aid consortium to make sure that they have access to radio operators that can use those baseline capabilities. And ability to access WinLink, the ability to access RRINTS nets, etc. And I think that's a point we lose sight of. And I think Cindy mentioned, there's, in the likely scenario in the Pacific Northwest with the Cascadia, event, subduction zone event, you may have no power. You may have no power for weeks. Things start to fall apart pretty rapidly in terms of standby power, diesel fuel deliveries, generators, things of this nature in a catastrophic disaster. We're not talking about the F5 tornado that impacts, 2 counties in a state. We're talking about, major disasters here. So, having the ability to fall back on the basic common denominators is, I think, an important kind of thing. I have somebody waving their hand here. I see you. Go ahead, and your turn to talk.
Me?
It's you. Yes.
Well, I'm very happy to be part of what you guys are doing today. I was my current call sign is it's very, very new, because I live in the Virgin Islands now. But to make the story long short, I was one of the guys in Puerto Rico who handled the 2,000 messages during Hurricane Maria. My old call sign at the day was KK4DCX. You want to look it up and follow the story. We did improvise, myself and my friend Whiskey Papa 4 on Sierra Delta, and Whiskey Papa 4 Kilo Echo Yankee. We were the 3 gentlemen that with no prior training at all. I mean, we worked from scratch, figuring out every second how to improve what we were doing. And thank God for the gentlemen in the United States that collaborated with us. More than 50 stations helped us on that endeavor, which lasted like 3 to 4 days. I remember after Hurricane Maria, everything in my house was a disaster. To be honest with you, I was able to save my radio, and we improvised a inverted V with number 14 gauge wire that I still have as a memorabilia for what happened that day. and we started calling, and the United States responded really good. And we were actually called for one of the inventions to get an award. We were there, and I met Valerie. I forgot her name, but Valerie was one of the 50 assigned that went to Puerto Rico. And I said to Valerie, what happened in Puerto Rico? Do we have Aries in Puerto Rico? And yeah, we do. But, it was like there was no protocol. There was no practice. Nobody was expecting what was going on. And I myself, with my two other friends, we did what we did with no experience, with no knowledge, with no protocol, with no logistic, no nothing. We just knew that time was in essence, and we needed to get this type of health and welfare messages across from Puerto Rico and members of the families in the United States, because it was chaos. So, being that said, I didn't say that I created the Aries Group Zone 5, but I was the one that a few years after Maria, to try to initiate to not open the club, but to have an Aries Zone 5. And I got the support, and I was the EC for a while. We had active participation on the earthquakes. We were deployed there as well. But programs like things that you guys are doing right now help everybody to have a model to be more, let's say, more. I can't even find the words, man. But so the reality is that when you are in the emergency, some of these things you're gonna forget.
Yeah.
Some of these things that you write in paper is gonna forget, and it's really important. Like the contact. I know you mentioned earlier that it's not enough to make the contact. But what you're going to do with the message, how's it going to get the message? Is the message going to, is it going to reach the final destination? Will it not? Where is it going to go, the message? These things are important. But what happened in Maria, it was an impacting experience. I still have dreams about it. It was terrible, terrible. I mean, we actually hooked up our station the second day after Maria, and then we started. And very slowly and progressively, the phone started to work, and then we pretty much stopped the transmission. But if there's anybody out there that's listening to me right now, sometimes you got to take the bull by the horns and do what you got to do. And sometimes government wants to take over. In Puerto Rico right now, the government made a pool of amateur radio operators. And you have a lot of people in Puerto Rico right now ready for any type of emergency. And Aries Zone 5, if you want to research it, it's active. I passed the EC to some one of the gentlemen that's there right now, because I'm recently moved to Virgin Islands, and but I'm still I'm ready. I'm ready. I mean, the experience was out of the blue, no rehearsal. And but these things are really interesting. And what can I say, man? So many things to say about what happened in Maria. That
Yeah, understand. One quick question to kind of close before you move on to others like Mr. Perez, but which mode did you use? I know the answer, but I want to hear you say it.
Well, right now we were blessed on 20 meters, man.
Single sideband, right?
Single sideband, 20 meters, one radio.
Right.
We were less than 100 watts.
Right.
And I tell you, there's always a debate whether I need 1,000 watts, 5,000 watts. I need a $5,000 antenna. My friend, I did only 33 feet. Yeah, 33 feet worth of antenna. Did a little, raggedy choke.
Yeah.
Put my wire, boom, propagation, done.
Yeah, of course. My point being, you use the common denominator mode. You use single sideband, and it's nice to say that people are supposed to come over and type messages into laptop computers, and you're supposed to be printing messages. And
there's no time for that. There's no time for that. In a real emergency, there's no time for that. There is no time for that.
Right.
It's just a simple radio, voice, and hopefully somebody will relay the message. I mean, a lot of things happen in Puerto Rico. It's a big island.
Oh, yeah.
And I'm sure that a lot of amateur radio operators along the island also did their thing, because I got friends that also did services for students in an international program exchange. There were a lot of people from other countries that they also wanted to do, know about their families. And I recently learned about a story that some people in Europe were kind of saying, no, stay away, stay away. They were like guarding the frequency. They were like,
Yeah.
but yeah, it was simple, single sideband.
Yep, and that's I wanted others to hear that, because
And
that's why we stress the importance of those common denominators.
my
I should
isolators, my isolators, 1/2-inch PVC pipes.
Yeah.
We had no
Mhm.
power. You know
Yep.
how I did the holes? I pounded a nail of one corner, and then I kind of squeezed it in and made my holes. We were working quick,
Right,
because
right.
when you were in a disaster, you don't have materials. You don't have the luxury of a Home Depot.
Right. Yeah, makes perfect sense.
You
Well,
know,
let me,
you
yeah,
got to learn from scratch.
sure,
Like I
sure.
tell my guys, learn from scratch how to get on the air.
Yeah.
What's the protocol? Whoever survives is the protocol.
Yeah.
Whoever's there first, you be the net control. Whoever's there first, that's what you got to do. And that's what my guys in Zone 5 are ready for. Whoever survives and gets on the air, he's in.
Great advice. Let me move to Mr. Perez. He has his hand up, because we're going to run out of time here pretty soon. But Heriberto, it's your turn, sir. Go ahead.
Yeah, I'm the one who's talking, Heriberto. That's me.
Oh, I see. Oh, I'm sorry. I thought it was a different guy. I saw a guy up here in another corner. I apologize.
No,
Forgive
it's me. It's
the
me.
screen's a little confusing. Okay,
Yeah, it's
so
okay. It's okay. So my during Maria, my call sign was KK4DCX. Okay.
KK4DCX. Okay.
Yeah.
Sounds good. Well, thank you so much for being here. I got a lot of people saying they're out of time, and so are there any? Are there any other comments, questions, rotten tomatoes, or anything before we finish up tonight?
I just want to thank you for doing these. I think that the dialogue and your training together is going to have positive influences on the future of the amateur radio service.
I appreciate that. Thank you very much, Dan. Really do appreciate it. Any other comments or anything before we go?
You have another hand up.
Yeah. I must be missing it. Who has their hand up?
It's James.
Oh, there you go. So yeah, go ahead.
Hi. Off-topic question. I understand that these are recorded. Are the links to the prior recordings published? I missed the August 4th one, and I wanted to take a look at it.
Not yet, but the main reason is I was on vacation for about 10 days, and then of course I got back home and had a big stack of problems from work, but I will get them posted here within the next few days. Yeah.
Understood, and thank you.
Okay, thanks. Yeah. Okay, anybody else?
James, again, appreciate it from Puerto Rico. Continue that magnificent work. I'm going to be in all the sessions to learn more about it. And well, 73.
73. Thank you very much, sir. Really appreciate it. Thank you. Okay, with that, I think that's a great place to close. So anyway, gentlemen, thank you for being here. You can always reach out to me via email if you have any questions, concerns, comments, etc. And we will see you, I guess, in about 2 weeks for the next training class. Everybody have a wonderful day. Thank you for being here.